Displacement is overall displacement. Velocity and acceleration are instantaneous. It's implied in the language. So I'll use x, delta x, v, and a. When are they positive, 0, or negative? And in terms of notation, I'm borrowing it from math. If, for example, one of these happens from A to B, including A and B, you would write that as A, B. So this is from A to B, including A and B. A to C, from A to C, including A and C. So you don't have to write B in there, since if you write A comma C, then B is in the mix. So includes endpoints and points in between. If it happens from A to B, including B but not A, parenthesis next to A, a bracket next to B. So this is from A to B, not including A. I guess including B, but not A. And so if I, let's say, parenthesis AD,
B and C. Is it going to include B and C on?
more than just B and C,
So,
Everything in between?
everything in between A and D. Not A and D though. If something happens at just point A only, then just write A. Or if it happens at A and D, A and D. One other piece of information, just to avoid potential confusion later. The problem starts just after ball leaves hand and ends just before ball touches ground. Awesome.
so does that mean that is A considered the starting point, or
Yes.
is the hand?
Well, technically A is the time when the ball is at the starting point.
Okay, all right.
If you look at the old test, some of the earlier tests, I got sloppy with the language and I just said A was the starting point as opposed to technically A is the time when the ball is at the starting point. All right. Take about 5-10 minutes. Try to do this on your own or with someone near you. And then we will talk as a group and then we will do a test level problem.
The last notation, AD without parentheses,
So this would be
that's excluding A and B. A
not,
and B.
not including A and B.
And the last one? that
It's
was
just point A and just point B. Or time A and time B. Nothing in between. So this and this would comprise the entire set. Because this is from A to D, not including A and D, and that's the points A and D.
Did you say that? Oh, wait, never mind.
Okay.
You want a table like that, like you put in your.
When I present the answer, I'm gonna use the table like this. There are other ways of presenting it. There's a PowerPoint that's posted, that I'm pretty sure I posted for this group, where I talk about 4 different ways of expressing the final answer. So if you have a better way you wish to express the answer, I'm open to that. But I plan to, as a group, present it this way, and then I'll talk about other methods of presenting. Awesome.
I just wanted to see if some of the assumptions I made here were right.
You said flip the order, okay?
Should be positive. Yeah.
Because position, so when you say the ground, the ball sits on top of the ground, so is it?
The problem is just more touches.
Oh, so that,
You're,
so then it was.
It's still
right,
positive.
yes, you're right, that's right. That's right, that is not. Wait. Yeah, that's right.
So this is all?
Yep.
Because once you hit the position, where you start going, if you have to go past.
Which spreadsheet software did you say you use?
I use OpenOffice.
OpenOffice? I've been messing with Excel.
Imagine it's a straight line, not the.
One thing that Excel has that is easier than OpenOffice is if you want to do programming. Programming in Excel being basic is simpler than programming in OpenOffice.
Yeah, well, I've never touched that function before.
Okay. The commands are still the same. And there's some other eccentric differences you can get used to. The thing is, Excel, every time you open up, one of them, every time you open up a new spreadsheet, it basically opens up the program again. And the other one, you have the base program, and the extra, bringing up extra spreadsheets does not take up that much more memory. So there's a lot more memory if you have just one, less memory if you have multiple. Right now, can't remember which is which.
Velocities cost. Right before it touches the floor. So it doesn't, because it doesn't speed up. But then he goes.
Well, I would think it was slowing down after pushing it up.
Yeah,
And then
we
it's-
go from A to B.
Yes, from A to B, it's slowing down, and then from B to D, it's speeding up, right?
No, it's constant. So it's going first, second, right?
That's the thing, is notations, we include A and B.
It doesn't speed up or slow down. I mean, from it's the one that comes up.
It's a zero, it's a zero, like velocity.
It is there.
That doesn't
It's-
mean-
it's not- it's not like that.
It was slowed down, going up, and then at B it stays 0, and then from B to D it's
It's
speeding up.
constant. It's constant.
Why is it constant?
Not a constant, yeah, I'm pretty sure it's speeding up,
Because.
because gravity's up and down.
point you're in velocity though.
Yeah.
Acceleration
From
Velocity.
velocity?
as soon as it gets to.
But it changes its direction.
Is there a
It's gonna
speed?
stop.
But from,
Before you
from
can
A
go
to,
to change direction, you
A
have
to
to.
B.
Yeah, first.
Zero.
So with the-
Negative.
from A to B, it's slowing
Velocity.
down.
With the velocity from A to C, it's positive, right, not including
Um,
C. But then
Really? Because I
at
would think,
C, it's 0. Or, excuse me, at B.
at B it's
it's
zero.
0.
And then from B,
Made to be
from
slow
B to
down.
D,
Oh, this is the final.
Yeah.
Hold on, I'm looking, I'm sorry, I'm looking at my
So
slide.
it's gonna be
Never
the
mind.
same.
So from A to B, not
It's the
including
same
D.
sign.
It's positive.
Velocity.
I thought it was
And
negative.
B, huh?
But wouldn't it stay the same?
Wait.
Because it's moving
Can
in
you
a
give us any
positive direction.
consideration?
Yeah.
So with velocity, because
Is
it's
it all
moving in
going
the
the same
positive
speed
direction,
right
it's
now?
positive.
I was gonna
If
say
it's stagnant,
acceleration
it's
is
0,
negative,
because it's
because
moving in the negative direction.
The ball goes up?
You're
Every
right.
single time it's gonna go slower.
Oh.
So
But B is
acceleration.
zero.
Yeah, at
It's
B
gonna
is
be
0,
negative
and then
A
from
to
B
B.
to D, it's
No,
Negative.
Cause then, once it's going down, it's gonna go faster. And the velocity is negative, and so it would be the opposite, right?
It does think so. That makes sense.
Okay, so.
Yeah, that's good.
Over time, it's gonna get slower, right?
Yeah, because you have the force.
Yeah.
Ooh, that's just That's slowing down. So that means.
It's a classic mistake with acceleration.
On that point,
Yeah, you did as well.
Has the opposite sign.
There's that dream that, everyone in the class get acceleration right the first time.
Acceleration.
Yeah.
Just slow down. I hope so. I would continue with not actually peak.
That's what I got. They are backwards.
Yeah. Literally.
Can I just,
So,
no one said, the equation for this, for
Problem
this,
starts right after all these.
all this one,
And in between.
and in between.
So for example, position, I said up was
As
positive,
soon as it leaves the
and ground
ground,
is 0. Wait, balls is positive side of the entire time.
Oh, here, okay, what I was thinking is, what is this,
So you're right,
this is
you are, because it says.
the A and then there's positive for the first, for just the position, and then,
Yeah, I think I'm just a little bit confused.
If you look, it sounds like you're just looking at.
Can you check mine?
A, B, C, and D, but it's A, between A.
Just tell me which
C,
one's wrong.
between B and C, C, between C and D and G. There's actually 1, 2, 3, 4, 5, 6, 7 different.
A, as you know, he said going up is A. So. you're
Time
going up
intervals?
from A
In a
to
sense?
Like, I'll just tell you without explaining it.
You can explain it too, I mean,
Yeah, but it's.
Listen to the explanation.
Much bigger, no? Because that's why I was trying to separate.
This whole thing?
That's why I choose that, because if not,
Because
Eh,
remember when,
let's say, these have to,
It says going up is
open, no, that I can,
Like-
that we can.
So that's what leaves it.
so, because before he was like, this is your, this is ground,
No, alright,
and
so position is
this is all
positive.
positive, this is
So
all
you would
negative.
write here,
And
that's
then, but
square
then,
bracket,
there,
A, comma, D,
the ground is
close
here,
square
and
bracket.
everything there is positive.
And the,
So,
these two.
therefore, like, all the positions.
So you don't need a lot of space. That's one of the reasons why I was choosing this location was.
Do you get it?
Yeah, no, I did get that. We were arguing that. We were like talking about considering that as a 0, because he did say that was a 0. And I was telling him he can't be negative until it reaches that.
Then
Yeah,
So
so,
these
for
are all-
So it
position,
starts at point A,
for position, it can only
it
be
stops at point
positive.
D, so
And
A, D.
Yeah.
But for starting point
That takes
is
into
for,
account everything.
Displacement
Yeah,
velocity.
okay, but then, where you write the other one, and where you write the other one.
Okay. So are these right?
Not quite.
Because for these, we did consider that as a starting point.
If, let's say that, if I answer that, I answer just this triangle, right?
Also is,
This piece of the
Yeah, positive, zero, negative.
Trajectory.
oh, the trajectory, I'm sorry.
Except position's positive also along here.
yeah.
Yeah, but the position is positive
I think
all
this
the
is not
time.
including A, because that A
So
is
you
like
can-
at the origin, like at the starting
Alright,
point.
so
So
after we put
that's
things in brackets,
technically
I'll
zero.
give another.
But isn't that when it says it doesn't start till it leaves the hand? So as soon as it leaves the hand,
But he was like,
That
at
means-
A, it's
I'll
at
set
the
up a grid.
origin.
ooh, okay, yeah.
That's why,
Good
that's
idea.
why this is zero, because if A was not,
Yeah, that's why that's zero, because it's, so it's from A to C, not including
and
A.
A and C are zero.
And then that's right, it's from C to D,
Yes,
not including C, says that's a zero.
yes.
Ooh, nice. Okay, so all those are positive, and it includes all of them, right? So if I rewrite that as that, that's correct, and that's not.
above the origin is positive.
Yes.
A to D, okay, and then what about velocity?
And then
And
for,
velocity,
Alright,
so it just
You have
depends on
C
dimension,
included as
but
positive
at
here
B,
because
it's
it's square
zero
bracket.
because
You have
it's at
C
the
included
peak.
as negative
At B,
here.
okay, so I got
Yeah.
that, for B is a P, and I
Without,
probably
of
don't
course,
wanna
the
include
traditional
that,
ribbon
right?
space-time.
Yeah,
That's a zero as well, or is that correct?
yeah, that's correct.
Okay.
Yeah.
And
Yeah, I
then-
don't think I know
You explained these pretty well, so.
Yeah, I think this is correct.
These two, the bottom two?
Oh, wait. Well, the acceleration is acceleration of gravity, and gravity only acts
Yeah,
downwards.
sure, if you're gonna do it this way, I'll just test that.
So, like, the acceleration is
C
always
is not
negative.
included, because C is included here.
So from A to D, not including
The
A,
ground is the origin.
No, everything is
From the starting point, so
because
this is
gravity.
And D is
it's making it slow
just
down,
before it touches the ground.
right? Or is it staying constant? Oh, it's staying constant.
Gravity is just acting downwards.
He said for zero origin,
The ground itself. It never actually, it never makes it there during the.
So it's from A to that negative.
A to C, because this is
Yeah,
the origin,
it's
this is the starting point, this is the from A to C, it's positive,
Uh,
including C.
I'm gonna leave that, because her.
Yeah.
I got that wrong the first time, so I was like, what?
Which one, the acceleration?
Yeah.
Yeah, that one's confusing. It's like you gotta think backwards.
So it's the positive side.
Oh, I thought it was zero because, so you go up, and then once you go down, it's gonna reach the same point. So that's why, for zero.
And then A to D here, A to C, close bracket. So that is always positive, right? Because it's all on top of the one.
In order, yeah, in order for it to be negative,
They
you
have
have
to
to
be
break the degree.
right for the ground, yeah.
Yeah,
That's
I
what
see.
happens.
Yeah.
So everything above the starting point is positive. And then for the, displacement from A to C, because it's all above the starting point,
But do you?
including C.
No, I don't think you include it because that's a zero.
You didn't include C?
Yeah, remember how he was doing that problem where you walk and then you walk back, you get your back.
But it's right above, but it's right above the origin, not past the origin. 'Cause it says it's on just
No,
after the. I'm
Displacement,
sorry, the starting point.
displacement is considered the starting point. So like, you start here, and you go back to the starting point, displacement is zero. You're,
Okay, okay, that's right.
Yeah, that's what I.
Okay, I see what you're saying.
All right, let's take a look as a group, and I know not everyone's done, but we need to reconvene. And the the huge number of people watching this video are gonna wonder, am I just gonna stare at the board the entire time? All part of the dream. Most prolific, unwatched creator of YouTube videos. Rarely one. All right, so position, because the ground is the origin and the ball never gets to the ground. Because again, problem ends just before the ball touches the ground. It is positive the entire time. Because up is positive and position cares about where it is relative to the origin. So this is from A to D. Not there, not there. positive the entire time. Another way of expressing the same thing is in a chart like this, where it's just positive the entire time. And the advantage of the grid form like this is that it emphasizes the fact that it is the 4 points that I defined specifically, but it also includes everything in between. All right. Any questions about the fact why the position is positive the entire time? All right, displacement. Displacement cares about where an object is relative to the starting point. Well, the starting point is at point A because starts just after ball leaves hand, and time is A is the time just after ball leaves hand. So the displacement is 0 at time A. At time, and then at C, it's at the exact same location. So all we've basically done is, it's in a sense, the displacement versus position, it's just changing your coordinate system. So position cares about here, displacement cares about here. So displacement's positive when it's above there, it's negative when it's below there. And the reason it's positive when I say it's positive above there is because I said up was positive. So it's positive from A to C. And then negative from C to D. So over here, it is 0 here, 0 here, positive from A to C, not including them, and then negative afterwards. Another thing this chart illustrates is the fact that you cannot go from positive to negative without going through 0. There is one test where it did happen because I misworded one of my definitions. And in that situation, I had much more flexibility into what the correct answer was because I screwed up. But when you go from positive to negative, you need to pass through 0. Velocity cares about the direction you're moving. Positive one going up, negative one going down. At B, it's at rest, by nature of the fact that it's at the peak. And so my velocity starts out moving up, and not including B for positive, and then all the way down, D to D. Positive before that and negative after. And then acceleration. As it is moving upwards, is it speeding up or slowing down? So the velocity and acceleration need to be opposite signs. So as it's going up, acceleration has to be the opposite sign. As it's going down, speeding up or slowing down. So it's the same sign. And that leaves this pesky one right here. But if you think about it, if I'm going from, so up is positive, so if I have going at 10 meters per second here and at negative 10 meters per second there, my change in velocity is negative. So that's negative as well. Potentially easier to think of in terms of force after it has left the hand. And remember, no Jedi powers here. After it has left the hand, what force is acting on the ball?
Gravity.
I'll nitpick that one later. Yes, and which way does the force of gravity act?
Down.
Towards the planet. And down, its force of gravity is acting on it the entire time. Downwards, which is negative. I saw some people still working under this idea that when it stops, the acceleration is 0. That would be a really cool effect if you could do that, because if acceleration is 0 when at the peak, that means there's no change in velocity. So the ball, you throw the ball in the air, it stops and then stays there hovering. However, I would contend, if that's the way physics worked, we as a species would have exterminated ourselves years ago. Imagine though, you jump into the air and never come down. All right, questions to hear? All right, so let's add a little bit of excitement to this. Let's graph it. More specifically, let's sketch a graph. Graphs, plural. And so when I say sketch, this is not a precise thing. We're doing this mess. Oh, Roberto.
Yeah, why in this graph okay, no, you say AD, no, okay, sorry.
All right.
Yeah.
So position versus time, velocity versus time, acceleration versus time. Now there are a couple of characteristics here. One, whether it's positive or negative, in other words, above the time axis or below the time axis, needs to match what we have right here, or what we have over there. The other thing is that velocity is the slope of my position graph, and acceleration is the slope of the velocity graph. So all those things need to be in common. Also, other than potentially at the endpoints, because the problem stops, begins, and ends, it should be differentiable in between, no sharp points. Now, on this one, it's a little bit easier than the one we'll do next. But so it starts out, I know the ground is 0, it stays positive the entire time. I'm just putting a little dotted line here, just as a placeholder. This in theory is the peak, so that would be point B. That would be A. That would be C, and then that would be D. My recommendation is that on a test, use a pencil the first round through, unless you're feeling really confident. Velocity, I know, is positive, so, and it's 0 at B, so we'll at least get that down. So that's my point B right there. It's positive, and it does match what I have here, because since this is the slope of that, it is indeed positive from the start to the end. So my slope starts like that, my slope gets less and less, so my velocity starts high and then goes to 0. And then over here, my velocity starts at 0 and then becomes more and more negative. And then acceleration needs to be the slope of that. Now, I drew this as a straight line, so my slope would be
The same?
as this? Or you're saying constant? Yeah, it would be constant, and yes, that's what I'm going for. Thanks for the mind reading. And that matches what we have right here. That's negative the entire time. And so this matches what I have over here, or that, and that. And they are consistent within themselves. So this is the slope of that, seems close enough, and that's the slope of this. So at this point, I could go ahead and connect that. And because acceleration is constant, this should be part of a parabola, and this should be a straight line, and that should be flat. a slope point, I should say, but. Alright. Questions before we tackle the test level problem? Or, any questions? Want to stretch legs, come back, feel refreshed, raring to go while I write up the problem?
George, you put this, the acceleration like positive, was not negative all the time?
Acceleration was negative all the time.
Okay, I saw that you put it above the axis in that graph.
Oh, no, my axis was here, and then I drew my acceleration down here.
Okay, minus G then,
Yeah, that's the trouble with two straight lines and using the same color ink.
okay.